Hello everyone. In this session, we discuss about second optimization problem called job scheduling problem. This is also one of the most popular problem. What is job scheduling problem? So job scheduling problem, nothing but we have a set of n jobs with a processing time. They have to run on a machine in a sequential order. So here my objective is to find the sequence of jobs that I arrange so that all jobs completes with the minimum completion time. So suppose a machine is running several jobs simultaneously. Optimizing that machine is important because if we optimize a sequence of jobs in a particular order, within less time only we can complete that work. So here input is a set of jobs, objective is find a sequence of jobs to process, and main objective is we have to find the sequence that takes less completion time. Means sum of completion for all jobs is less, and assumptions are jobs are processed sequentially, there is no preemption, release times are there, no release time. That means once it is started, you have to complete the job. How we find the sequence of these jobs? Using a local search algorithm we see. First search algorithm, here hill climbing. How hill climbing solve? First we represent the states, then we represent the objective function, then we represent the neighbors, and we find the neighbor states. Let us see how we can use this job search one by one. Suppose a machine is running 5 jobs. J1 equal to 5, J2 equal to 3, J3 equal to 8, J4 equal to 2. That means there are 5 jobs. J1 job takes 5 seconds to complete. It may be second, minute, hour. J1 first job is taking 5 seconds to complete, second job taking 3 seconds to complete, third job 8 seconds, fourth job 2 seconds, fifth job 6 seconds. Now these are the completion time of a jobs. Now I have to find the order of these jobs, or find the sequence of these jobs in a order that takes less time. Now in which sequence I can complete all jobs in less time, I have to find. Let us arrange them in one vector, J1, J2, J3, J4, J5 vectors. Index of first one is 0, 1, 2, 3, 4. I formulate the problem. First I take the completion times, then I give indexes to each job. Now first initial hill climbing starts with the initial sequence. Suppose randomly I take one sequence 2, 4, 0, 1, 3. This is the sequence I take it as the initial sequence. That means 2 means it's a J3, nothing but what is the order of completion of the jobs? 2 means it's J3. From J3 then I go to completing job J5, then I go to J1, then I go to J2, lastly I take J4. So for this sequence represents this order of job completions. Now J3 takes 2 seconds to complete. After J3, J5 comes into the line. Now how much time taken to complete the J5? Already 2 plus 2 seconds taken by J3. Now J5 takes another 4 seconds. That means here it takes 2 plus 4. J1 takes these are completion times. J3, sorry, here. Here so J3 is 8. Yet the completion times J5 is 6. 8 plus 6, that is 14. Next J1. J1 takes 5 seconds. So 8 plus 6 plus 5. J2 takes 3 seconds. That means 8 plus 6 plus 5 plus 3. J4 takes 2 seconds. So it is 8 plus 6 plus 5 plus 3 plus 2. So how I now combine them together, like it is 8 plus 14 plus here it is 19 22 plus 24. So what the total time taken by this sequence is around it is 87. So there are 87 seconds required to complete this entire sequence. Now what I do, is it a less time, is this sequence is correct or not? What we do, we try to find one neighbor that is taking less than 87. So what I do, I make a slight changes to this initial, like I swap these two. I make a 4, 2, 0, 1, 3. That means what is the order of the jobs I execute? J5, J3, J1, J2, J4. So J5 takes 6 seconds, J3 takes 8 plus 6, 14, and J1 19, J2 22, 24. So if you sum all these costs, you get 85. That means earlier sequence is taking 87 seconds to complete all the jobs on the machine. This sequence taking only 85 seconds to complete all the jobs in the scene. So this is the initial state, initial sequence. This is a first neighbor. We can find one more neighbor. You can take another neighbor, like by making a small I choose this neighbor based on swapping. So I can also choose a neighbor by shifting its positions, like I choose 4, 2 and 4, 1, 0, 2, 3. I shifted these two places, not a swap. Here I shifted now. When I use this sequence again, I get 75 as my cost. So this initial, first neighbor, second neighbor is giving 75. Like this, I use either swapping or shifting. I find these, I make arrangements to these sequences. My final cost is reduced from 87, 75. Like that, I find the final optimum solution that takes a very less time of completion of these jobs. Like this hill climbing algorithm, at every stage it finds the neighbors and calculates the job completion time. So when you do it iteratively, you find one sequence, like you practice it in home, 3, 1, 0, 2, 4. This is the sequence that give you 57 as the total cost to complete. 7 seconds will take to complete the jobs. Means what is the order in this 3 Ju means 3 means first we take the J3, then you take J1, then you take J2, J1, J3 and last one J5. This is the final sequence, optimum sequence that is generated, that takes only 57 seconds. Like this, job scheduling is done using hill climbing algorithms. Every step we start with one sequence, we make one neighbor by swapping, or you can make another neighbor by shifting. This process is done iteratively until we find the best sequence. So this is application of a hill climbing algorithm for solving job scheduling. Second algorithm is simulated annealing. As I told you, simulated annealing, as in previous TSP problem, here also what I do, I set temperature as 1000. Initially I start a random permutation of the jobs and set temperature as 1000 and its cooling rate is 995. Evaluate at each state, try to compute the completion time of the sequence. Based on that, generate the neighbor. Neighbor is accepted if it is a lower completion time. If it is you get a worst neighbor who has the very highest time, try to take the accept that worst condition and track the probability of getting the correct state from that neighbor who has given worst output. Worst means very high completion time. Suppose one neighbor gives 10 seconds, another neighbor gives 50 seconds, means we accept that worst condition and calculate what is the probability of getting a correct neighbor from that worst condition by using e power minus delta minus t. So as TSP here also we follow, it's like all the jobs are given. First sequence, random sequence 24013. For this we get the 87 as I calculated. Initial temperature I set it as 1000 and then I generate a new neighbor sequence as 42013 by making the initial state small changes in initial state. Then here got is 85 current and its previous, I get a change in energy as -2. So -2 is accepted because it is less than 0 near. So you take this as a current state and again find the neighbors of this state. Now this is my new state and I create a neighbor of this state. This time I get total time 65, means slowly I am reducing the completion time. So delta energy difference 20. It's worse because we should be within the points, so 0 to 1, but it is 10. But we can accept this 20. If I accept the 20, what is the probability of getting another state that take less time by calculating the probability value? So this process will goes on until your temperature is 0.1. Slowly I am reducing the temperature at every cost. Earlier I took temperature as 1000. Now I set a temperature as 0.961 into 1000. That means around 995. That temperature slowly I decrease up to 0.1. So this is a simulated annealing process to solve job scheduling problem. So we discuss next in other session we discuss genetic algorithm that can solve TSP's job scheduling in one single session. Thank you.